Let's look at our first example. Here we're going to multiply the square root of 3a times the square root of 6a. Now, when we're multiplying radicals, we can multiply the radicands. So in other words, we can rewrite this expression as the square root of 3 times 6, 18, a times a squared. Once we get to this point, we have to make sure that our radical is in simplified form. Being in simplified form means making sure that there are no factors of the radicand that are perfect squares. Now hopefully this is getting easier for you at this point. The square root of 18 does have a factor that's a perfect square. In fact, that's 9. So we have the square root of 18 as 9 times 2 and the square root of a squared off to the end. Now notice here we also have a perfect square, a squared. Perfect square, that's going to be 3. So both of the front and the last ones, here and here, can be simplified. The square root of 9, 3, the square root of a squared, a, and the poor 2 has to remain under the radical symbol. So we say that this product simplifies down to 3a times the square root of 2. Let's try another one of these. Right up here. Again, we're going to multiply what's outside the radical sign together, and we're going to multiply what's inside, or we're going to multiply those radicands together. So we're going to multiply on the outside of this 4 times 2x, which is 8x. We're going to multiply the radicands together, 3x times 6x, 18x squared. Once we do that, we're back to the same problem we had over here. What we have to do is look for factors of the radicand that are perfect squares. So again, since we have the same number that we just had, the square root of 18, we recognize that as 9 times 2 times the square root of x squared. The square root of 9 is going to simplify to 3, so this gives me 8x times 3 times the square root of 2 times x. And notice x is not under the radical anymore because we had the square root of x squared. Now we can multiply all the terms that are outside the radical sign. So we're going to have 8x times 3, which is 24x, and multiplied by that x at the very end gives me x squared. Again, 3 times 4, 24, x times x, x squared. And again, the poor number 2 must stay under the radical sign. So we can say that this product here simplifies down to 24x squared times the square root of 2. Now that we did that simple multiplication, let's see what happens when we try to incorporate the distributive property to these radicals. Let's look at the distributive property. If we have 2 times the square root of x times 4 times the square root of x minus x times the square root of 2, let's see what happens. Again, as I just mentioned, we're going to use the distributive property. 2x times 4x. Now the key is this: when you're multiplying radicals, whatever's on the outside of the radical sign gets multiplied together. Whatever's on the inside of the radical sign gets multiplied together as well. So these two numbers, 2 and 4, since they're both outside the radical, becomes our product of 8. Inside the radical on this one, we have the square root of x times the square root of x, which is going to give me the square root of x squared. Now we can see that's a perfect square, but we'll simplify that in our next step. Now continuing with our distributive property, we're going to multiply those two together. Again, keep in mind you multiply the outside numbers together and the inside numbers together. So here we go. 2 times negative x is negative 2x. And inside the radical, or the radicands, x times 2 to give us 2x. That may look a little bit strange, but that's the correct answer so far. Now, we have one thing left to do, and that is right here. I see I have a perfect square as a radicand. So this can simplify simply to x. There's nothing I can do here to simplify. It's in simplified form. So I'm going to leave this as 2x times the square root of 2x. Now, don't be tempted to combine these two terms. This 8x does not have a radical portion. So because it doesn't, these two are different terms. Notice they're not like terms because the radical portions are not the same. In fact, this doesn't even have a radical portion. So don't be overzealous and try to simplify that. This is the final answer. Now that we use our distributive property, how about foiling? Do we think we can foil some of our radicals? I think we can. Let's look at this example. The square root of 6 plus the square root of 5 times the square root of 2 plus 2 times the square root of 5. Again, we have a binomial. That means we have two terms times a binomial. And you should be at your point in your algebraic careers to recognize that when we multiply binomials, we use the foiling method, or also referred to as the extended distributive property. So let's go ahead and FOIL. Remember the first two terms, root 6 times root 2, would give us a product of the square root of 12. So again, I'm multiplying the first two terms together. Now O in FOIL tells me to multiply my outside two terms together. We're going to multiply those two together. Now be very careful because it's easy to make a mistake here. 2 is the only number on the outside. 6 and 5 are both radicands. So what we're going to do is multiply 2 times 1, which is 2, and then remember in front of anything that doesn't have a number out front, times inside the radical sign, 6 times 5, 30. So far we have F and we have O. Now we're ready for I. I is to multiply the two inside terms. Notice in my two inside terms, I have numbers under the radical sign, or I have just simply two radicands. So I'm going to multiply those together. 5 times 2 is 10. That gives me my I. Finally here, I'm going to multiply my two last terms together. Now be very careful. On the outside we have a 2, so we're going to multiply 2. And then we have 5 radicands of 5, which give me a product of 25. That completes my FOIL. Now, our job at this point then is to go back and make sure that there are no factors of the radicands that are perfect squares, and also to make sure that no radicands are perfect squares itself. I hope you see right away that 12 has a factor that's a perfect square. In fact, 12 is 4 times 3. 30, no factors that are perfect squares, so we leave that second term alone. The square root of 10, no factors that are perfect squares, so we leave that alone. And at the end down here, I see the square root of 25. That's a perfect square, so we're going to replace that simply with 5. Our last step then is to do the multiplication. We know that the square root of 4 is 2 times the square root of 3 there, plus 2, this one is not changing, square root of 30. The third term is neither changing, the square root of 10. And finally, the last term, we can look at the product 2 times 5 and write 10 there. Now, what we're saying then is when we multiply this binomial times this binomial here, we get the product and this is in simplified form, 2 root 3 plus 2 root 30 plus the square root of 10 plus 10. Check to make sure, do we have any of their factors that are perfect squares? No. Do we have any radicands that are the same? So because we do not, this is simplified form of the product of my two binomials. Just keep your eye out for factors that are perfect squares. Make sure you simplify them and have some fun.